Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. So we're gonna continue where we left off now, okay? So remember in the previous video, we learned how to use these three fundamentals formulas to calculate whatever that was required from us, right? In today's video, we're gonna be looking at now stoichiometric calculations. Now we are gonna look at little bit interesting questions dealing with these things now. Instead of just giving you one information, they will give you information about the other, okay? So what do I mean by that? I'm gonna have I want you to look at the steps to follow, okay? Steps, okay? Steps to calculate effectively the stoichiometric calculations. Number one, calculate calculate the number of moles of the known substance using either these formulas, using either number of moles is equal to mass divided by molar mass, or number of moles is equal to like that, or okay, using either of these formulas. Okay, this is step number one. Depending on the information that you are given, you're going to use one of these formulas. Step number two, use the mole ratio between the known and the unknown. That's step number two. I'll explain it more. Okay, let me explain step number two before I move on. As using the mole ratio, I want you to refer to the ratios as you did in mathematics, okay? It's like, okay, if Mpho and Lebu are in a ratio of 1:2, it means whatever that Mpho has, Lebu has double of that, okay? This is what the ratio has. So basically means that if Mpho has 5 rand, it means Lebu has how much? What is double of 5 rand? It means Lebu has 10 rand, okay? Similarly, if Mpho has maybe something like 2 rand, it means Lebu has 4 rand. Okay? We can also use it, we can do this using Lebu and say if Lebu has 8 rand, it means, remember, if Lebu has double of that, it means Mpho has how much? Then we can say, okay, if you do not know, if you're not that good with mathematics, you can say this is X and do your cross multiply and say this times that, it is 8 rand, it is equal to this times that, it is 2x. Then when you solve for x, 2, then x, it is equal to how much? 4 rand. It tells you that if Lebu has 8 rand, it means Mpho has how much? Has 4 rand. So that is the ratio of what? 1:2. Similarly, even if I can have a ratio of 2:3, and then Mpho has okay, let's now talk about moles. Okay, let's talk about moles. If let's say carbon dioxide, between carbon dioxide as well as calcium carbonate. Okay, let's say now the ratio it is 2:3, and then we now know the number of moles of carbon dioxide. Okay, let's say the number of moles of carbon dioxide it is 0.5, and we want to know the number of moles of calcium carbonate. Okay, so what we might do, we cross multiply 2 multiplied by x, 2x, it is equal to 0.5 multiplied by 3, this 1.5, and then x is going to be equal to divide by 2 by 2, 0.75 what? Moles of calcium carbonate. Okay, yes. So this is basically that what we're going to be doing in the mole ratio. And then after getting the mole ratio of the unknown, okay, you're going to use this formula for number 3. Use, okay, solve for the unknown using either of these. Using either of these, N is equal to mass divided by molar mass. N is equal to V divided by molar volume. N is equal to number of particles divided by Avogadro's constant. Or using now the last formula that says C is equal to N divided by V. So these are the three steps that we need to follow. Okay. Let me make an example so that before we go to actual examples, okay, let's say let me see if I won't take one of the questions here. I'm gonna take it. Okay, let me say magnesium reacts with, okay, let me say magnesium. Another thing you need to know before I move on to examples. This is very important. NB, you need to know how to balance a chemical equation. Very, very, very important. If you do not know how to balance a chemical equation, you will get answers incorrect. Okay, yes. Let me have an example here. An example, it says magnesium, which is Mg, reacts with oxygen with, let me say, with 12 grams of oxygen to produce magnesium oxide. Okay. So now, what I need you to do first, it is to write the balanced chemical reaction. Which one reacts with what? So magnesium reacts with what? With oxygen to produce what? Magnesium oxide, not dioxide. So now is this balanced? No. Why? Because can you see our oxygens here? There are two oxygens in here. There's one oxygen here. So how can I make these oxygens to be two in here? I need to put a two here. If I put a two here, can you see now my oxygens, it is two here, and two multiplied by one, it is two there. But now my magnesium, it is two in this side and one on that side. So I need to put two here. It is now balanced. Okay. Okay, let's say the question says, okay, the question says, number one, calculate the what? The mass of magnesium oxide produced. How do I know this is a, I need to apply stoichiometric calculations? Okay, I'll say, okay, what is the question requiring from me? The question wants me to calculate the what? The mass of magnesium oxide. And remember, every time when they say mass, I need to calculate the molar mass of that particular substance. So the molar mass of magnesium oxide is going to be 24 plus 16, which is 40. And then, do I have number of moles of magnesium oxide? No, I do not. Okay. And remember, for me to use this formula, M is number of moles is equal to mass divided by molar mass. I need to, at least if I have number of moles and molar mass and then have this one unknown, I can use it. But now, can you see I have two unknowns, which is the mass as well as the number of moles? What is it that I can do? What is it that I can do? What I can do is, okay, I can use the information that I have. What information do I have? I'm told that 12 grams of oxygen is reacted. Again, So 12 grams of oxygen reacts. So I'll say, okay, let me use the information that I have. Okay, the known information. The known information is that I have the mass of oxygen. It is equal to 12 grams. What is now molar mass of oxygen? It's going to be 2 multiplied by 16 again, which is equal to, let me say 2 times 16 because people will say they don't understand, which is how much? 32. And then can I get number of moles of O2? Yes, I can get number of moles of O2. I feel like I need space here. Okay, I can calculate number of moles of O2. So it means I will say N number of moles is equal to mass divided by molar mass. Then number of moles is equal to, what is my mass? 12 divided by 32. Then number of moles of what? Of O2, it is equal to what? Then let me quickly punch my calculator. 12 divided by 30, sorry, 12 divided by 32, it is 0.375. This is not the final answer. It's not round off. If it is not your final answer, you round off to a minimum of 4 decimal. Is this, am I done? No. Why? Because they said calculate the mass of magnesium oxide. And then I just calculated the mass, the number of moles of oxygen. How is it going to help me? Oxygen and magnesium hydroxide. This is oxygen and this is magnesium oxide. Sorry, not hydroxide, oxide. So remember, as first steps, it says, first thing, calculate the number of moles of the known substance. What is the known substance? It is oxygen. I know the information about it. And then second step says, use mole ratio between the known and the unknown. Okay, I'm done with the first step. Okay, I'm done with the first step here. I need to go to the second step, which is using what? The mole ratio between the known and the unknown. What does that mean? The known is the what? The known is oxygen. Oxygen is the known. What is the unknown? The unknown is the one that they want me to calculate, which is magnesium oxide. Magnesium oxide. What is the mole ratio between those two? I look at the coefficient. What is O2? O2 has a coefficient of 1. So it's going to be 1 is 2. What is a mole ratio for MgO? It has a coefficient of how much? Of 2. So it is 1 is 2, 2. You do not guess these. Hence, I say you need to find this balanced equation. Because if this was 1 here, it was going to be, if remember, we wrote it like this initially. Again, it was unbalanced. If you continue with this as unbalanced, you are going to say 1 is to 1, and it's wrong. So hence, you need to do what? To balance it first. You need to balance your equation first. Then, what do I know here? I know that the number of moles of O2, it is how much? 0.375 is to what is number of moles of magnesium oxide? I do not know. Remember, I do not know the number of moles of what? Of magnesium oxide. So I can find them by saying, okay, x multiplied by 1, it is x is equal to 2 multiplied by 0.375, which is the same as how much? 2 multiplied by this, it is the same as multiplied by 2, 0.75. But now this 0.75, it is what? You need to tell us, oh, okay, I calculated this 0.75, but it is what in actual fact? This 0.75, it is what? Remember, it is the what? Number of moles of what? Of magnesium oxide. Then you tell us, oh, okay, I know it is 0.75 what? Moles. And now, can you see now, you now have the number of moles of this one, which is now 0.75 moles. Do you agree with me now? I can now use this information to calculate the whatever information that they want. What is it that they want? They want my mass. So it means I can say on number 3, number 3 says now, solve for the unknown using either of these. Okay, how can I solve for the unknown now? It means now I have what? Number of moles is equal to mass divided by molar mass. What is number of moles of MgO? I just found it to be 0.75 using my mole ratio. Molar mass, it is how much? So my mass, it is how much? It is what I'm looking for. What is molar mass of MgO? MgO, it is, we calculated here as, let me remove this and put it here. We calculated it to be how much? To be 40. And then I can say, therefore, mass of magnesium oxide, it is equal to how much? you can say 40 multiplied by 0.75. Then you get something like 30 grams. You are done. Always, you need 3 steps every time when you're dealing with stoichiometric calculations, especially in grade 11. Hence, I say this video is specifically for grade 11s because there's no way you're going to be given the question that is easy like these ones. You might find one of these, but mostly it will be based on stoichiometric calculations. I repeat, step 1, you find the number of moles of the known, the one that you have more information about. Number 2, you use the mole ratio between the one that has more information and the one that they want you to calculate the information, whatever variable for. And then step number 3, you calculate for the unknown. Okay. Again, let's apply 3 steps here. Okay, let's quickly answer these simple questions before we move on to serious things. What does the symbol G means? It means the gaseous phase. Okay. Then what does sufficient O2 means? It means now, okay, it says a chemical reaction represented by the equation below takes place in sufficient O2. Sufficient O2 means there is enough, okay? Enough O2 to react with CH4. Okay, yeah. We do not necessarily need the theory, but you just know it. Is the equation balanced? Explain your answer. Okay. Now let's look. Carbon, how many carbons here? 1 carbon, 1 carbon. Sharp. Hydrogen, 4 hydrogen, 2 times 2, which is 4 hydrogen. Sharp. Carbon, how many oxygens? 4 oxygen, 2 times 2, which is 4. And then I have 2 plus 2 there, which is 4. So the answer is yes. Why? There are 4 carbons. So there are 1 carbon, 4 hydrogen, and 4 oxygens on both sides. Okay, yes. They won't ask you this question. They will just say balance it if it is unbalanced. Now, name this chemical reaction. This chemical reaction, okay, the chemical reaction that between something that reacts with oxygen and form carbon dioxide and water, it is called combustion, okay? It is a combustion reaction where our alkane, when you do grade 12, you'll see this is alkane. Okay, when CH4 or CH something reacts with oxygen, okay, and form carbon dioxide and water, it is a combustion reaction, okay? When people are burning tires, okay, in the street, when they are doing ito and all of that, they are creating a combustion reaction. Let's look at 1.3.5, what I want us to look at today on this video. It says now 8 grams of CH4 react with O2. Calculate what? Number of moles of calcium, number of moles of CH4. CH4, it is methane that were used, okay? So number of moles of methane that were used. So we collect our data first. Remember, how do I collect my data? I'm going to say, okay, what do I have about CH4? They want me to calculate the number of moles of CH4. So I'm going to say they want me to calculate the number of moles of CH4. If they want me to calculate, I'm doing a question mark. What is it that I'm giving about CH4? I'm giving mass of CH4. So I'm going to say mass of CH4, it is equal to how much? 8 grams. Remember, grams, it is for mass. And remember, if I'm given the mass of something, I need to calculate what for that particular something. It's molar mass. So what is molar mass of CH4? It's going to be C, it is 12 plus 4 into this 4 into what is molar mass, atomic mass of hydrogen, it is 1. Then I get something like 16 grams per mole. And then can I now calculate number A? 13.5, number A, 1.3.5, number A. Yes, I can calculate because I have this. It means I can calculate that one. How? Number of moles is equal to mass divided by molar mass. What is number of moles? It is 8 divided by 16. The number of moles of CH4 that were used is going to be 0.5 moles. Okay, can you see that? Yes. Now, they say, okay, I'm going to erase this and just remember this now. I'm going to say, okay, number B, calculate the theoretical mass of oxygen. They want me to calculate the mass of oxygen. Okay, immediately when they say mass of oxygen, I'm going to need the molar mass of oxygen, which is how much? Which is 32 by now. It is 2 multiplied by 16, 32 grams per mole. But remember, I'm going to need number of moles of what? Of O2. Do I know them? No. Okay, let's continue. The theoretical mass of O2 that reacts with CH4. Okay, so now that reacts with CH4. Okay, so it means now we will need to use the. Okay, can I now calculate the mass from this information? No. Why? Because no, I do not know the number of moles of O2. Okay, so what is it that I need to do? Remember, the first step says what? It means now, if I'm having two unknowns and one known, it means now I cannot use a equation like that. So this tells me I need to use what? Stoichiometry. Stoichiometry. How? Step one. Step one is me calculating the what? The number of moles of the known. Okay, what is the known? The known, it is CH4. Calculate the number of moles. But when I check, I already calculated the number of moles of the known on number A. Okay, I now have step number one. Step number one, completed on question number A. Okay, on question number A. Let's look at step number two. Step number two says what? Use the mole ratio between the known and the unknown. What is the known? The known, it is CH4. What is the unknown? The unknown is the one that I need to calculate for. What is it that my question needs me to calculate for? It is O2. So I need my mole ratio between CH4 as well as what? O2. Now, the mole ratio between CH4 and O2 is how much? Let's check here. CH4, it is 1. O2, it is 2. Can you see? It is 1 and 2. 1, 2. So it means the mole ratio between CH4 and this one, it is 1 is to 2. What do I know about CH4? The number of moles of CH4, it is how much? 0.5. And then of O2, I do not know. Then I need to calculate x multiplied by 1 gives me x. Then 0.5 multiplied by 2, it gives me 1. Okay, but now this x is what? What is it that I just calculated? I calculated the number of moles of O2. X is the same as number of moles of O2, which is 1 mole. I get, or we can say 1 moles. Okay, then I'm done with step 2. Step 1 completed. Okay, step 2, nice. It's even nicer that they started with A, so that they guide you. Then I need to complete step number 3, which says what? I now know the mass of this. So the number of moles of oxygen, which is what? 1. Again, again. Then you can say 1 mole or 1 moles, it's fine. Then I am now in a position of calculating what? The mass of O2, because I have this, I have this. Okay. Then step 3, as it says, calculate the unknown. So calculate the unknown. Okay. So how can I calculate the unknown? I might say, okay, number of moles, it is equal to mass divided by molar mass. What is number of moles? 1. What is my mass? I'm looking for that. And then what is my molar mass? Molar mass, it is 32. And then when I do my mathematics, mass of O2, it gives me something like 32 grams. Can you see the questions? They are going to be like this. Step 1, step 2, step 3. Here on number A, you did step 1. Again, they won't tell you. Then number 2, you just need to do step 2 and step 3. But you collecting your data, you will see if you need to do stoichiometric calculations or not. Let's look at the other question so that we understand this better. Okay. This one says now, if 4,480 centimeter cubed of O2 reacts with sulfur at STP, calculate the what? Number A, the theoretical mass of S that burned in the O2. Okay, so they wanted the what? The mass of S. Let's see if I have enough information to calculate for S. Number A, I want to calculate the what? Calculate the theoretical mass of S, okay? This is what the question asked me. I do not know. What information do I know about? Okay, every time when they say mass of something, I need its molar mass. Molar mass of sulfur, it is 32 grams per mole. Again. And then I need number of moles of sulfur. Do I have number of moles of sulfur? No, I do not have. Remember, if I have two unknowns, it tells me that I need to use what? Stoichiometry. This is how I will know that I need to use stoichiometry. And then it means now I have to start by using what? My known. What is my known? It means now I need to complete step one. Step one. Step one, I need to do what on step one? What is it that I need to do on step one? I need to calculate the number of moles of the known. Number of moles of the known. This is step one. Which one is the known? Can you see that I have, and remember at STP that molar volume, it is equal to 22.4. I have what? Volume of O2. I have. Then, can you see now, on the information of the known, let's look at the known, which is O2. I have the volume of the known, which is O2, which is equal to 4480 centimeter cubed, that I need to divide by a 1000 so that I get 4,48 decimeter cubed. Okay, then I have at STP, I know at STP, every time when they say STP, I know my molar volume, it is 22.4. I get, okay, then I can I get number of moles of the known? Yes. Why? Using which formula? Using this formula. And it is equal to what? V divided by molar volume. Okay, then what is number of moles? I do not know. What is my volume? My volume, it is 4,48 here. Again, then divide by what is my molar volume? 22.4. Then I can get the what? Number of moles of O2, which is the what? The known. Okay, I can say 4.48 divided by 22.4. It gives me something like 0.2. What? 0.2 what? Moles. I'm done with step one. Okay, I need to do what? Step two, which says me I should use what? Mole ratio between what? The known and the unknown. Okay, what is the known? What is the known? The known, it is O2. And what is the unknown? The unknown is what I'm trying to calculate for, which is what? Which is sulfur. So I need to say O2 is to sulfur. The mole ratio between O2 and sulfur. Oh, I forgot to take out the reaction for this one. Let me quickly fetch it. Okay, either way, it's going to form you something like this. I'll just balance this equation for you. It's going to be sulfur plus O2 to form sulfur trioxide. And then it's going to be 3 here. It's going to be 2 here. It's going to be 2 here. It's fine. So here is the equation. What is the mole ratio between sulfur and oxygen? Oxygen and sulfur. You need to write down this order very carefully. Okay, the known and the unknown. Even if you can say the unknown and the known, as long when you write O2, its mole ratio, it is how much? It is 3. Can you see? Here it is 3. So O2, I come and say it is 3 is 2. For sulfur, it is how much? For sulfur, it is 2. Okay, for sulfur, it is 2. And then what do I know? What is the number of moles of O2? Number of moles of O2, it is 0.2. Number of moles of sulfur, I do not know. Then I use my what? My calculation there using ratios. It's going to be 3 multiplied by x, it is 3x, it is equal to 0.2 multiplied by 2, it is 0.4. And then that tells me x, which is the same as number of moles of sulfur. Remember, x is number of moles of sulfur because we're calculating number of moles of sulfur in here. It is equal to what? When I say 4 divided by 3, sorry, 0.4 divided by 3, it gives me something like 0.133. Remember, if it is not your final answer for decimal, again, if it is not your final answer for decimal, now that I know the number of moles of sulfur, I can say, okay, I now have this one. Again, can I now calculate the mass of sulfur? Yes, yes, I can. How? Can say, therefore, step 3, calculate mass of sulfur. Okay? Because calculate the what of the unknown. The unknown, it is what? Mass of sulfur. So I can say I now have what? Molar mass and so as number of moles. So it means the formula that I might use, it is number of moles, it is equal to mass divided by molar mass. Number of moles of sulfur, it is how much? 0.1333. Then mass is what I'm looking for. Molar mass of sulfur, 32. And then mass of sulfur thereof gives me something like 0.1333 multiplied by 32. Then I get something like 2 decimal. Remember, final answer is going to be 4. This is now my final answer. 4, comma what? 7 grams. I'm done. Can you see? Always 3 steps. Step 1, number of moles of the unknown. Step 2, use the mole ratio. Step 3, you calculate for the unknown. Okay? Sorry. Step 1, use the known. Step 2, mole ratio between the known and the unknown. Step 3, calculate the unknown. How easy is that? I guess. Then let's clear this up and now look at what? Okay, let me erase this. Remember, we need to conserve this one. We're gonna use it more often. Okay, we have already calculated this, so we might need this again. Number of moles of the node. Okay, let's now answer number B. Oh, sorry. Let me quickly do this. I'll bring it back to the screen that we all can see. I want to raise this quickly. Okay. Then here. Okay. Then done. Done. Good. Now let's look at number B. Number B says what? Calculate the theoretical volume of SO2 that was collected at where? At STP. So we want what? The theoretical volume. We are collecting the data. We want the volume of what? Of SO2. Oh, so it means it's going to form SO2. Actually, I did not see how this formula was. Okay, allow me to change this question and say SO3. Yeah. Okay, it's fine. Calculate the mass of SO3 that was collected in STP. Okay, so the volume of SO3. So we want the volume that was collected at STP. We know at STP the molar volume it is 22.4. I'm gonna need what? For me to calculate this one, I'm gonna need number of moles of SO3. Do I have? No. If I do not know, then it tells me automatically I need to use what? Stoichiometry. I need to use what? Stoichiometry. Then now, remember step 1 of stoichiometry? is me calculating what? Step 1, number of moles of the what? Of the known. What is the known? The known it is O2. Do I know? But yes, if I were to check, I already know step 1. Okay? I can just say number of moles of the known, which is CH4. I already have that. So not CH4. O2, I have already calculated that, which is 0.2 moles. It's done. No need to recalculate if you have already calculated it. Okay? Then let's look at step 2. Ratio. Mole ratio. Between what? The known, which is O2, and the unknown is what we are looking for, which is SO3. Okay? Then it means here I might say, okay, let me look at this and say the mole ratio between O2 and SO3, it is what? What is O2? O2, it is 3. What is SO3? SO3, it is 2. So it is 3 to 2. The ratio, it is 3:2. What is now number of moles of O2? 0.2. What is number of moles of SO2? I'm looking for that. Then if you do your mathematics correctly, you're going to get 3x is equal to 0.4. And then you'll see that x, which is the same as number of moles of SO3, in this case, it is the same as that one we calculated before. Okay, 0.1333 moles. Okay, and then I'm done with step 2. Okay, now I know the number of moles of what? Of this one. I get, and then it means now I can complete step number 3. I say I need to calculate what? The unknown. What is my unknown? I look at my information. It says my unknown, since when I have this and then I now have this, my unknown is going to be volume. So I'm going to calculate the volume of SO3. Then, which in this case is going to be using this formula. Which formula? I look at my data here. I have V molar volume and this one N. Then I choose my formula that says N it is equal to V divided by molar volume. What is N? N it is 0.1333. What is my volume? It is what I'm looking for. Remember, calculate VO3. My molar volume at STP is 22.4. And then when I calculate the volume of SO3, it gives me something like 0.1333 multiplied by 22.4, which in this case gives me 2.99 watt decimeter cubed. Okay, yes. So this is what I get. I'm done with step number 3. So and then it means I am done. Can you see how easy these questions are? Let's look at the last question for the day or for this one. It says, this one I extracted it from a question paper. It says, learners prepare a solution of sodium hydroxide in water by placing 8 grams of sodium hydroxide in a volumetric flask and adding water to water to produce 250 centimeter cubed of solution after stirring. Okay, stirring, not stirring as like in the movie. We have the mass of sodium hydroxide as well as the volume. Okay, remember what is concentration? Concentration, it is the amount, so the number of moles. How do I know concentration? I'm going to say C is equal to N divided by V. So it's going to be what? The number of moles per what? Per volume, or someone might say liter of a solution. I'm done. The amount of the number of moles per divided is per volume of a solution. Then calculate the concentration of sodium hydroxide concentration. I need to collect my data. What do I have? What do I have? Let's look at 6.2.2. It wants me to calculate the concentration of, let me use a different color. It wants me to calculate the concentration of sodium hydroxide. Question mark, I want to calculate that. What information do I know? I have what? sodium hydroxide in water by placing 8 grams of sodium hydroxide. I have, remember grams, it is mass of sodium hydroxide. And remember, every time when I'm given a mass of something, I need to calculate its molar mass. So we already calculated this in some of the previous videos. You can repeat that. Remember, Na, it is 23, plus oxygen, it is 16, plus H, it is 1. Then it's going to give you 24 plus 16, which is actual 40. Okay. Then every time when they say mass, I need molar mass. If you can know that in your head, bon, you are done. And then I'm given also volume, 250 centimeter cubed, volume of sodium hydroxide. In this case, it is 250 centimeter cubed, but I need to divide that by 1000 because I want my volume to be in what? In decimeter cubed. So it's going to be 0.25 decimeter cubed. Then I can say, okay, let me see. Do I have a formula that looks like this? That's Cm molar mass and what? Yes. Remember, I have C is equal to mass divided by molar mass multiplied by volume. Can I calculate concentration? Yes, and easily so. Mass 8, okay, molar mass, and every time they like this type of question, they like it a lot. If it does not appear on the paper, I don't know. What is molar mass? Molar mass, it is 40. What is my volume? 0.25. Then when I punch my calculator or I do this in my head, I know this is going to be 8 divided by 10, which is going to be 0.8 mole per decimeter cubed. Do not forget the negative. How do I know that concentration? It is what? Remember, it is what is N? N, it is in mole, then divide by decimeter cubed. Or you can write this as mole per decimeter positive cubed. Or if we are using mathematics, if you remember mathematics, laws of exponents, A divided by N is the same as A multiplied by N to the power of -1. So if I want to write this in that form, is going to be mole multiplied by the denominator to the power of negative exponent. Yeah. So that is that for number one, 6.2.2. I've calculated that as 0.8 mole per decimeter cubed. Now it's 6.3. So in 6.3, we are moving away from this information. We are done with that information. So it means we won't use either of that information anymore because it is a new question now. Let me create a space and then try to calculate that for us. 6.2.6.3 rather. 6.3, okay. 6.3 says sodium azide, which is NaN3, is used in car airbags. For airbag to inflate the following must take place. So we have 2 moles of sodium azide forming, it is decomposing to form 2 moles of sodium plus 2 moles of nitrogen. Like that, it is balanced, okay? 2 moles of sodium, 2 moles of sodium, 2 times 3, so it means it is 6 of sodium, nitrogen and 6 of nitrogen balanced. They say now, calculate the volume of nitrogen gas, okay? We are collecting our data. Volume of nitrogen gas that will be produced at STP, okay? Produced at STP, remember, I know that my molar volume is 22.4. And then, can I calculate now the volume of this one? Remember, I need number of moles of N2, right? Do I know it? No. Then, remember what? I need stoichiometry. Remember, on every data that you have, number of moles, it's either it's there or it is unknown. And it is always there on all the formulas. So now, if I'm going to use stoichiometry, I need the information of this is the unknown. Again, I'm going to need my known. What is my known? I'm told that if 55 grams of sodium azide reacts completely, so sodium azide, I know the information about sodium azide. I'm given the mass of what? Sodium azide as how much? 55 grams. Immediately when I'm given the mass of something, I need to calculate the molar mass of that something. Okay, so sodium is going to be 23 plus 3 into 14. Then how much do we get? I'm going to 23 plus 3 into 14. How much do I get today? I get something like 65 in that. Grams per mole. Then can I get number of moles of sodium azide? Yes, I can, because why? I know mass, I know molar mass. Then remember, stoichiometry says 3 steps. Step number 1, calculate what? Number of moles of what? Of the known. And this is what I need to do. The known, remember, it is sodium azide in this case. So I'm going to say number of moles is equal to what? Mass divided by molar mass. How do I know I use this formula? I look at my information, M, molar mass, and number of moles. Then I choose the correct equation. And it is equal to what is mass? 55. What is molar mass? 65. Then number of moles of, I need to indicate number of moles of what? Of sodium azide. It is 55 divided by 65, which it gives me. This is not a final answer. So for decimal, 0.8462 moles. Okay, if it's not a final answer for decimal. And then I go to step number 2. Step number 2, it is the ratio, mole ratio between the known and the unknown. What is my known? Sodium azide, as well as what is my unknown? My unknown, it is N2. Okay. How can I do that? I'm gonna say, okay, N8, N3 is 2, N2. What is the mole ratio there? Let's look at that. NaN2, it is 2 here. What is Na or N2? It is 3. So it is 2 is to 3. 2 is to 3. Then what is number of moles of sodium azide? It is 0.8462 is 2. What is this one? I'm looking for that. Then X, it is equal to, actually, it's going to be, again, it is X multiplied by 2. It gives me 2X. It is equal to 0. That one multiplied by 3. It gives me something like 0.8462 multiplied by 3. It gives me something like 2.55386. Then X, it is equal to, I'm dividing that by 2, something like 1,2693. But remember, what is X? Remember what is X? X, it is number of moles of N2. So I'm going to say number of moles of N2, it is equal to 1,2693 what? Moles. Now I'm done with step 2. Okay? I completed step 1. I'm done with step 2. I need step 3. Remember, I now know this 1,2693. Can I now calculate my volume, which is my unknown? Yes. Why? Because I now know the what? The number of moles. So can I use this one? Yes. Using which formula? For step 3, I'm going to calculate my unknown, which is volume of what? Of nitrogen. Then which formula am I using? This one that says N is equal to V divided by molar volume. Number of moles, 1,2693. Volume, molar volume, 22.4. And then volume, 22.4 here. Volume of N2, in actual fact, it is something like 28.43 decimeter cubed. Step 3, done. Then you are done. Can you see? Everywhere we've been doing step 1, step 2, step 3. So that's basically that for stoichiometric calculations. Let's look, in the next video, we're going to be looking at limiting reagents. Okay, what exactly we refer to as limiting reagents. Okay, so on the next video, please join me when we'll be looking at limiting reagents. We're gonna use the very same step, okay? But now you need to know which one is the limiting reagent first, okay? Yes. So yeah, that's basically that from me. And hopefully you enjoyed the video, and yeah, let's meet on the next one, okay? Um, let's see how I exit this. Okay.